Good morning to Madam Seri, and to my friends. Today, me and my group member will present about end of chapter 2, which is our title is Temperature Control System. Before we go through the next slide, allow me to introduce myself first. My name is Frankie John, while my other group members is Nur Adlan Khairulatnam bin Nurlaji. So, first of all, about the system identification, the temperature control system is an embedded system designed to automatically monitor and regulate temperature within a specific range. It uses sensors to detect the surrounding temperature, a microcontroller to process the data, and a actuator to maintain the desired condition. This system is widely used in incubators, air conditioners, server rooms, and greenhouses where precise temperature control is crucial. The main objective of this system is to maintain a stable environment without human intervention, ensuring safety, energy efficiency, and equipment with longevity. Move to the next slide, which is about system identification. The components include which is have six component also with the picture and the description and function. So first of all, the microcontroller which is Arduino Uno. The description and the function is act as the brain of the system. It receives data from the sensor and controls the fan or heater based on the temperature reading. Secondly, temperature sensor. The brand is LM35 slash DHT11. The description about this temperature sensor is to detect ambient temperature and converts it into an electrical signal that the Arduino can read. Third, the actuator, which is the fan slash heater. The description about this actuator is to perform the physical action by cooling or heating the area according to the microcontroller's command. Fourth, the relay module. The description and the function is works as a switch that safely connects low to voltage Arduino signals to high, which is the voltage devices. Fifth, the power supply, which is 5 to 12 volt DC. The description about this power supply is provides the required voltage to all components. And lastly, of the components is LCD display. Each is the description and the function is shows real-time temperature and system status. So, for the last slide for me to present is the system operation, which is about the temperature control system operates as a continuous loop based on the input to process to output principle. The input stage, the number one is the temperature sensor continuously measures the ambient temperature and sends a voltage signal proportional to the temperature value to the microcontroller. For example, in the LM35 sensor, to 10 MV represent 1 Celsius. Secondly is the processing stage. The Arduino microcontroller reads the temperature signal and compares it with a preset temperature limit. Example, 30 degrees Celsius. If the detected temperature is higher than the limit, the controller sends a signal to activate the fan or cooling device. And then, if the temperature is lower than the limit, the controller will turn off the fan or activate a heater depending on the setup. Lastly, the decision making process happens automatically and repeatedly, ensuring accurate control. And then, lastly, the output stage, which is the relay module receives the control signal and switches the connected actuator fan/heater on or off. The LCD display updates every few seconds to show the latest temperature reading and current system state. For example, fan on, it will get a signal 32 degrees Celsius. This creates a closed-loop control system where input feedback continuously affects output action. So, in summary, the system operates automatically without human input to continuously sensing, processing, and correcting temperature levels to maintain stability. So that's all from my present. So right now I will pass to my group member, which is Nur Adlan Khairul bin Nurlaji. Thank you.
So good afternoon, madam. So today I will continue Frankie part and I will continue this line. For the third one is system operation. The temperature control system operate as a continuous loop based on the input to process and to output principle. Okay. For the first one is input stage. The temperature sensor continuously measure the ambient temperature and sends a voltage signal proportional to the temperature value to the microcontroller. For example, in the LM35 sensor, 10 envelope represent 1 Celsius. For the second one is the processing stage. The Arduino microcontroller reads the temperature signal and compare it with a preset temperature limit, like 30 degree. The first one is the if the detected temperature is higher than the limit, the controller sends a signal to activate the fan or cooling device. If the temperature is lower than the limit, the controller will turn off the fan or activate a heater depending on the setup. The decision-making process happens automatically and repeatedly, ensuring accurate control. So for the third one is output stage. The relay module receives the control signal and switch the connected actuator on or off. The LCD display update every few seconds to show the latest temperature reading and current system state. This creates a closed loop control where input feedback continuously affect output action. So in summary, the system operates automatically without human input and continuously sensing, processing, and correcting temperature level to maintain stability. For the third one is real-time aspect. The real-time response is the key feature of the system. It ensures that any temperature change is detected and acted upon immediately, preventing the system from becoming unstable. So I will explain how real-time control works. The temperature sensor constantly sends update reading every few milliseconds to the microcontroller. So the microcontroller instantly process the data and decide the next action, that turning the fan or heater on or off. So the actuator response happen almost instantly without second of any change in temperature. For the importance of real-time response, it will keep the environment stable and avoid large temperature fluctuation. Second, it prevents overheating or overcooling, protecting sensitive components. For the third one, improve energy efficiency by ensuring the system operates only when needed. And the last one is it enhances safety and reliability, especially in systems that run for long period. For example scenario, if the surrounding temperature rise suddenly from 28 degree to 30 degree, the sensor detect it instantly. The microcontroller then process it and the fan active almost immediately. When the temperature return to 30 degrees Celsius, the fan is switched off automatically and all within real-time operation. So for the fifth one is block diagram. So this block diagram shows a closed loop temperature control system where to reference represent the desired temperature value. The controller receives the difference between the reference and the actual temperature measured by the sensor. Based on this error, the controller sends a control signal to the system or actuator to adjust the temperature, either by heating or cooling. The sensor continuously measures the output temperature and feed it back to the controller, allowing real-time adjustment to maintain a stable and accurate temperature level. So this setup demonstrates how sensor feedback, microcontroller logic, and actuator control work together in real time to maintain stable temperature condition. So, in summary, The, temper- the temperature control system is a simple yet powerful embedded application that integrates sensing, decision making, and actuation. Its real-time control, closed-loop feedback, and automatic operation make it reliable, efficient, and ideal for real-world applications requiring consistent temperature management. So that's all from our team, me, Nuranan Kairanam, and Frankie John. Thank you.